Today we're going to learn how to write quadratic equations. Please remember, when you write a quadratic equation, it has to be in standard form. Now, standard form means the squaring comes first and the integer with no variable comes on the end. You can have a combination of addition signs and subtraction signs, all addition signs, or even all subtraction signs. So how do we write an equation given the roots? What are your roots? Your roots are your values of x. So let's write that for ourselves. So our roots actually are values of x. So that's when you do the t-bar and you find your values of x, those are called your roots. Okay, so you can find the sum of the roots by adding them, the product of the roots by multiplying them, and then you substitute them into the following equation. This following equation is very important. It's something that you need to memorize, especially when they ask you to write the equation from the given roots. All right, so let's take a look at number 1. In number 1, they say write an equation whose roots are 2 and 5. So we're going to actually plug it into x squared minus the sum of x plus the product, and I'm just going to write PROD period equals 0. Okay, sum of who? Your roots. So off to the side, we're going to find the sum of our roots. So our sum is going to be 2 plus 5, which is 7. And our product is going to be 2 times 5, which is 10. And now we're going to substitute in. So we have x squared minus the sum, which is 7, times x, plus the product, which is 10, equals 0. So there is a quadratic equation whose roots are 2 and 5. Okay, let's move on. In number 2, they want us to write a quadratic equation in standard form with negative 2/3 and negative 5/2 as its roots. Okay, so again, we're going to use x squared minus the sum of x plus the product equals 0. All right, off to the side, we're going to find the sum and the product. Now, we're dealing with fractions, and if you're not really good with fractions, I totally suggest that you get your calculator out and put it in the calculator. So the sum is going to be negative 2/3 plus negative 5/2. And actually, this is exactly how you'd put it in the calculator. Then after you hit enter, you'd go math fraction, enter again, so that it would be simplified. And the sum comes out to be a negative 19/6. Product would be negative 2/3. Let's make that a nicer 3. Times negative 5/2. And that'll give you a positive 5/3. If you were doing it by hand, it would give you a positive 10/6, which reduces to 5/3. Okay, so now we're going to substitute it in. We're going to have x squared minus the sum of x, but my sum is already a negative. So a negative of a negative is going to become a positive 19/6x plus the product, which is 5/3, equals 0. Now, if you take a look at this, have you ever seen a quadratic equation with fractions? Hopefully you said no, because really there aren't quadratic equations with fractions. So we have to get rid of those denominators. So what we're going to do is going to multiply both sides by the LCD. Now, the reason we can do this is because when we multiply the right side by the LCD, anything times 0 is 0. So it's not really going to change what the quadratic equation is equal to. So my denominators are 6 and 3. The LCD would be, correct, you're right, 6. So I'm going to multiply this term by 6, this term by 6, and this term by 6. And then, of course, the other side of the equation by 6. Nothing cancels in the first term. The 6's cancel out in the middle term. And 3 can be reduced into 6 2 times. So let's see what we have left over. We have 6x squared plus 19x plus 10 equals 0. So there is our quadratic equation whose roots are negative 2/3 and a negative 5/2. All right, number 3. They want us to write a quadratic equation such that the sum of its roots is 6 and the product is negative 27. So in this case, they didn't give me the roots. They actually gave me the sum and the product. So we're going to start off with x squared minus the sum of x plus the product equals 0. And then we're just going to substitute in x squared minus 6x plus a negative 27 equals 0. So let's neaten that up again because we have a plus negative there. So it's going to be x squared minus 6x minus 27 equals 0. And there's my quadratic equation. Taking a look at the next part, sum and product of the roots. For any quadratic equation, ax squared plus bx plus c equals 0, the sum can be expressed as take the b value, negate it, and divide by the a. The product of the roots can be expressed as take the c value and divide it by the a. So this is when you want to find the sum and the product of the roots without actually having the roots. So you don't have to actually factor in t-bar and then take the values of x and add them and multiply. You can actually use your values of a, b, and c to produce the sum and product. All right, so let's take a look at number 4. What is the sum of the roots of this equation? Well, if I wanted to find the sum of the roots without actually having the roots, for the sum I would use a negative of b over a. Okay, b is a negative 11, so we have a negative of a negative 11 over a, which is 1. So it would be 11 over 1, which is 11. So my sum would be 11. Please remember you're substituting the b value into a negative of b. So if your b value is already a negative, it's going to be a negative of a negative. With that being said, let's look at number 5. What is the product of the roots of the equation 2x squared plus 9x plus 6 equals 0? Well, it's in standard form. I don't know the roots, so I can use the product formula, which is take your c value and divide it by your a value. All right, my c value is a 6. My a value is a 2. 6 divided by 2 is 3. That was pretty easy. Taking a look at number 6, if 2 is a root of the equation, x squared plus 3x plus k equals 0, what's the sum of the roots and what is the other root? And then find the value of k. All right, well, we already know one root, it's 2. So one root would be x equals 2. Well, now think about it. If x equals 2, can't I just substitute 2 in for x and find the value of k? Well, let's do that. So I'll have 2 squared plus 3 times 2 plus k equals 0. 2 squared is 4 plus 6 plus k equals 0. 10 plus k equals 0. Subtract 10 on both sides, k equals a negative 10. So I found the value of k. So now truly the equation is x squared plus 3x minus 10 equals 0. So they want me to find now the sum of the roots. Well, to find the sum, I can use a negative b over a. So b is 3 and a is a 1, so it's a negative of 3 over 1, which is a negative 3. Well, let's make that 3 a nicer 3. So I have a negative 3 for the sum, and I have my value of k. So what's left? The only thing else that's left is to find the other root. Well, now think about it. If I know the sum is a negative 3 and I know one root, so what plus 2 would give me the negative 3? So if I subtract 2 on both sides, x would equal a negative 5. So the other root would have to be a negative 5 in order for their sum to be a negative 3. So there was a lot of work to do there. We just had to kind of concentrate on what we could do first. So let's review. We knew that one root is 2, so therefore we set x equal to 2 because that's one of our roots. We took the 2 and plugged it into the x of the equation and found our value of k. Now we were able to, from there, write our quadratic equation. We took the quadratic equation and used negative b over a to find the sum, which is a negative 3. So then, if we know the sum is a negative 3 and one root is 2, what would the other root have to be to make the sum a negative 3? And we found it to be a negative 5. Let's take a look at number 7. Given the roots 1/2 and 2/3, write a quadratic equation with coefficients that are integers. Okay. All right, they gave us the roots and they want us to write the equation. So we're going to use the formula. X squared minus the sum of x plus the product equals 0. Okay, so we're going to find the sum and product. Sum, we're going to actually take out our calculator because it's fractions, unless we're really good with fractions. And we're going to have 1/2 plus 2/3. And if you put it in your calculator, you should end up with 7/6. Product means we're going to multiply 1/2 times 2/3. And in multiplying, we're going to end up with 2 6s, which is 1/3. So we're going to plug it in. X squared minus 7/6x plus 1/3 equals 0. Again, they want us to write a quadratic equation whose coefficients are integers. Well, a couple of my coefficients are fractions. They're not integers. So we're going to have to get them to be integers. And again, just like we said with a couple problems ago, we can't really have fractions in a quadratic equation. So we're going to eliminate the denominators by multiplying through by the LCD. Well, our denominators are 6 and 3, so the LCD will be 6. So we're going to multiply this term by 6. This term here by 6, this term by 6, and then also 0 by 6. In doing so, we'll be okay because anything times 0 is still 0. So let's see what we have. 6 times x squared is 6x squared. The 6's will cancel out. I get minus 7x. Plus 3 goes into 6 twice, so plus 2. So there is my quadratic equation whose coefficients are integers. One last problem. Number 8. If 3 is the root of the equation, what's the value of c? Well, what you have to realize is that 3 is a root, 3 is a value of x. So we're going to plug 3 into the x and find c. So we have 3 squared plus 4 times 3 plus c equals 0. 9 plus 12 plus c equals 0. 21 plus c equals 0. I'm going to subtract 21 on both sides, so c equals a negative 21. So my value of c is a negative 21. Okay, that'll end our notes for today, and that is the last set of notes for this unit. So coming shortly will be a test. If you'd like, you should start studying now. See you in class tomorrow.